By the end of the 16th century began the scientific revolution. Now, if you look at the scientific revolution, in fact, historians have tried to periodize the scientific revolution into three periods. One is during the time of the Renaissance, the second is the time of the wars of religion, and the third is during the time of the Restoration. Without actually going into the period of the scientific revolution, we will turn our attention to the beginnings of the scientific revolution, which actually started with the Copernican theory of heliocentricity. Now, the Copernican theory of heliocentricity is important primarily because it acted as a catalyst of change.
Inspired by Copernicus, Giordano Bruno wrote a book of infinity, the universe, and the world. In this book, he wrote, "If the earth was not the center of the universe, and all those stars clearly seen in the night sky were also suns, then there must exist an infinite number of earths in the universe, inhabited with other beings like ourselves." This idea about the universe was not accepted by the Catholic Church. They organized an inquisition and charged Bruno with heresy.
Now, the church actually came down heavily on the concept of heliocentricity because the concept of heliocentricity actually meant the cutting down of man to size. Now, it is actually also challenging the importance of man in the universe. Man is just a very small part of that huge universe which is actually governed by the sun.
Even a death sentence handed down by the Catholic Church did not change his attitude, as he defiantly told his accusers, "In pronouncing my sentence, your fear is greater than mine in hearing it." The Dominican monk Giordano Bruno was burnt at the stake on February 17, 1600. It was the twilight of the Italian Renaissance. Christianity was drained of its earlier humanism. The great artistic masterpieces of the Southern Renaissance were no longer being created. The Protestant Reformation was nearly a century old, and the Inquisition was in full force. Members of every church tended to make the same error, that since Christ was the central figure in history, then our own earth, the scene of Christ's death and resurrection, ought to be the center of the universe. Yet, in this hostile environment, flowered great minds that dared to defy old beliefs and bring about a paradigm shift in our perception of the universe.
Copernicus, in his turn, had a very profound influence on someone called Galileo Galilei.
Using spyglasses manufactured in Holland, Galileo built a telescope with a magnification factor of 20. With this new tool, he found mountains and craters on the moon. He discovered that the Milky Way was composed of stars. And he also discovered the 4 largest moons of Jupiter. In March 1610, he published his findings in the Starry Messenger. Galileo was a believer in Copernican theory. However, in 1616, Galileo was told by Cardinal Robert Bellarmine to no longer defend the concept that the earth moves around the sun. To avoid confrontation with the church, Galileo gave in. After singing a recantation of the Copernican theory and accepting the church's claim that the earth was unmoving, Galileo said, "And yet, it moves." He continued his work on determining longitudes at sea based on positions of Jupiter's satellites. He continued to study falling objects and penned a book on comets called the Essaya, which was published in 1623.
Another very significant contribution of Galileo Galilei in the field of science was this, that he developed two new sciences, the sciences of statics and dynamics. Now, these two sciences laid down the laws of motion, very important, and the mathematical theory of the strength of materials. You have another person who plays a very significant role, or whose contribution is very significant in the field of astronomy, and that is Tycho Brahe. Tycho Brahe is actually a Danish scientist, and with the help of the Danish king, he actually built a very important and the first, in fact, scientific institute of the modern world.
While attending the universities of Copenhagen and Leipzig to study law and philosophy, Tycho Brahe became interested in astronomy and spent most of his evening times studying the stars. One of Tycho Brahe's first contributions to astronomy was the detection and eventual correction of several grave errors in the standard astronomical tables. In 1572, he discovered a supernova located in the constellation of Cassiopeia. Eventually, his fame led King Frederick II of Denmark and Norway to make an offer of funding the construction of an astronomical observatory for him to work there. Tycho Brahe did not accept Copernicus's model of the universe. He attempted to combine it with the Ptolemaic model. He proposed that the 5 known planets revolved round the Sun, which, along with those planets, revolved around the Earth each year. Tycho Brahe's theories were incorrect, but the data he collected during his lifetime was far superior to any other data compilation made prior to the invention of the telescope. After Tycho Brahe's death, his assistant, Johannes Kepler, used Brahe's observations to calculate his own 3 laws of planetary motion.
Tycho's observation was further developed by Kepler. Kepler was a Protestant scientist. A very important book of his was the Mysterium Cosmographium, and he put forward the hypothesis of the elliptical orbits, which shattered the Pythagorean Platonic view of the circular motion of the heavenly bodies.
Johannes Kepler theorized that the Sun emitted a constant force across the planes of a planet's orbit, which diminished with distance. He believed this force pushed the planets around their orbits. In 1596, he published these theories in a treatise called Mysterium Cosmographicum, or Cosmographic Mystery. This was the first written defense of the Copernican model. In this book, geometric calculations have been used extensively to prove the theory. His next major work, entitled Astronomia Nova, or New Astronomy, was published in 1609. In this book, applying mathematical calculations to Tycho Brahe's data, he showed that the planet Mars had an elliptical orbit, with the Sun at one focus. Then, he extrapolated the idea of an elliptical orbit to other planets too. This was the first of Kepler's laws of planetary motion. The second, which also appeared in this work, is called the area rule, which says that a hypothetical line from the Sun to a planet sweeps out equal areas of an ellipse during equal intervals of time. This means that the closer a planet comes to the Sun, the faster it moves.
Galileo and Kepler, we find they were brilliant mathematicians. That is why they could make such near perfect calculations regarding the celestial world.
Kepler's work was later developed into the law of universal gravitation by Sir Isaac Newton. Meanwhile, there was flowering of revolutionary ideas in other fields too.
A very important figure or mathematician, you can say, during this time was Vieta. Vieta, he developed two branches of mathematics. One was algebra, the other was trigonometry. And this speeded up calculations, which of course will have which had an utilitarian value, which we will discuss later. Another important figure of this time was Simon Stevin. Simon Stevin, he introduced in 1568 the decimal system. Very, very important, and he provided the essential basis for a whole new science which was called hydrostatics. He was also the founder of hydraulics. You have Napier introducing logarithms, and Leonardo da Vinci, known for something else, was actually someone who was the founder of scientific engineering. In 1600, we have William Gilbert, who was the physician of Queen Elizabeth and also the president of the Royal College of Physicians, and he published something which was called De Magnete. It was a book which gave everything that all the known facts about magnetism. He concluded that the earth was a magnet. Very important, and it was the magnetic force that actually held the celestial bodies in their places. Nothing got to do with divinity. Challenging these misconceptions, proving by rationality, by observation, by experimentations how the celestial bodies were held in orbit. We find that his observations helped the work of Hartmann and in turn influenced someone called Robert Norman, very important, who was a mariner and a compass maker. Compass is very important because this was the time where you have the geographical discoveries, the desire to find new sea routes, specifically to the world of spices, that is the Orient. Gilbert's physical and non-mythical explanation of the universe later helped Newton. We will do that, come to that a little later. We also have Paracelsus, his developments or his contribution in the field of medicine, and we have Paracelsus actually challenging the established texts of Galen and the established texts of Hippocrates, and Paracelsus was someone who initiated the development of medicine, which was later taken up by people like Harvey. William Harvey is important because he was the first to find out that blood circulated in the body.
In 1628, William Harvey published his work, An Anatomical Exercise on the Motion of the Heart and Blood in Animals. Here, based on scientific methodology, he argued that blood was pumped around the body by the heart and recirculated in a closed system. This clashed with the accepted model of Galen, according to which venous blood originated in the liver and arterial blood in the heart. The blood flowed from those organs to all parts of the body where it was consumed. Harvey had based most of his conclusions on careful observations recorded during controlled experiments on various animals. He was the first person to study biology quantitatively.
In fact, his work reached its fruition under someone called Malfigé, who, with the help of the microscope, showed the flow of blood. That blood flowed. This was something which was shown by Malfigé with the help of the microscope. Harvey's discovery had the same impact in the field of medicine as we find Copernicus and Galileo Galilei's invention in the field of astronomy. Now, it was just as the sun was the center of the universe, Harvey proved that the heart was the center of the human body. It was the controlling force of the human body. These great discoveries, that is the circulation of blood and the fact that